Welcome to this lesson. We know that virtual crash can be used to make physics simulations of auto accidents, but it can be also used for creating pretty stunning looking crash diagrams. So we're going to go through an example of generating a crash diagram here. I've already loaded up a Google Earth aerial of a crash scene for this example. And I've already scaled it using the procedure demonstrated in another lesson. We're going to start by drawing polygons over our roads, and this just helps to create a better looking diagram, in my opinion. And for this we're going to use the polyline tool, and we'll just go over the aerial and outline the roadway. Okay, and of course we can update the vertices as we need in case we want to refine it. And we can make it semi-transparent to help us. And let's apply texture. We'll use the asphalt texture for this shape. And when we make the color less transparent, we'll be able to see the texture a little better. Let's go ahead and freeze that, and we'll go ahead and draw in the lines, lane lines. So here we have a double yellow line that we're going to draw in. It looks fairly straight, so the line tool should be suitable. And of course that's yellow. And we'll just create a clone, and we'll use the copy to move. It's that easy. Here again we have double yellow lane lines, and again it looks fairly straight. Now we have the bicycle lane. And we could put in some arrows for the bicycle lanes. Like so. Here we have a stop bar. And we have a stop sign. And we could change that sign to a stop sign simply by doing this. And we have our stop sign. So we have most of the features of the roadway. Let's go ahead and freeze these various elements for now. Now let's suppose that the police took some measurements and they used this line as their reference line. I'm just going to make it orange while we're doing the diagram. And let's suppose they used this lamp here as a reference point. Let's set up a coordinate axis. So this coordinate axis I just set up in an arbitrary orientation. We can fix it to any reference line in the scene or curve simply by picking a path node like so. And again, that could have been a curved line. Let's just show that feature using an arc, or how about a random curve. There you see the dimension line following the shape of our curve. Again, we want to use the reference line that the police marked at the scene. We can extend, let's call it our y-axis in the southern direction. and our x-axis in the west direction. And we can center this about that lamp. Now let's mark the pre-impact trajectories of both vehicles. Let's suppose vehicle 1 was coming along this direction, and this is sort of the path vehicle 1 would have taken had the impact not occurred. And for vehicle 2, maybe he stops at the stop sign, I would hope. Maybe not. And this would have been one possible trajectory taken by vehicle 2. And for vehicle 1, let's suppose it was a Volvo SUV. And let's make this red. And for vehicle 2, well, let's make that a little Toyota Yaris. Put them at the stop sign sometime before impact, like so. So there we have their positions well before impact. Let's go ahead and we'll use a copy and make a clone of vehicle 1 and put them at the position at impact. And let's suppose that there were markings, gouges in the roadway that were measured by the police, and so we know that the impact occurred in this area. Let's make a clone of the Toyota so that we can place the vehicle figure at impact. perhaps we know the impact orientation due to the crush damage patterns, and it's consistent with the pre-impact trajectory you would expect. So something like this. And maybe the police were kind enough to take some measurements of the post-impact positions with respect to the reference point, and let's suppose the SUV was over here. And the little car is over here. And of course we can draw lines for the post-impact trajectories. And we could put some labels in. And so we already have a pretty good looking diagram. Let's go ahead and freeze these elements. Maybe we want to go back to our overlay of the asphalt and make it a little more opaque. I always like to do that in my diagrams. I think it's a nice effect. And of course we could put the names of the roads and any other features, a dimension line if it's useful. And you have many options, rendering options, to choose from, depending on how you want to print out your diagram. So here we have a high quality rendering complete of our crash diagram, and you might have noticed one thing we're missing is crush damage to our vehicles. And of course, Virtual Crash, being a 3D modeling program as well as a simulator, allows us the ability to modify the vehicle shells. So we're just going to go ahead and do it, modify our vehicle shells to show crush damage. And we're just going to do that to our vehicles in the rest position. And you could be a little more precise if you had your own measurements. You can import your diagram of your measurements, or you can use the measuring tools within Virtual Crash to set the amount of deformation needed on the vehicle shell. Here we're just going to deform our shells and to show a reasonable crush damage pattern given the type of T-bone collision that we had for our case. So all you have to do is well, first make sure that your vehicles aren't frozen, and let's unfreeze them all. And go to faces mode. Now you can do this also in vertices mode, but it's good enough to go to faces mode, select proportional editing, and when it's a little hard to see because the vehicle's red. When you click on the vehicle, you'll notice, because we're in this faces mode, you're picking out particular polygons. So let's just, since this would have sustained, this SUV would have sustained front end damage, let's go ahead and pick some polygons, and you can begin just deforming the shape. And if you want, you can restrict the motion of your mouse to the XY plane. That might help make things a little easier. And the larger that red circle is, the more polygons will participate in the deformation. So if you want fewer polygons to be selected and pushed back with your mouse motion, then you just decrease the size of that circle. And the circle is controlled by the scroll wheel of your mouse. So let's just begin deforming. And we're just picking out certain polygons, and you can go down to the level of individual polygons if you want to. I don't really want to do that. And we'll just start pushing back sections. And you can deform lower polygons lower on the vehicle shell or higher on the vehicle shell. It's up to you, depending on what you need to show in your crush damage pattern for your case. Let's move on to our Toyota. And that would have received our sustained damage to the driver's side front. So we've included crush damage now on our vehicles at rest. And of course, where virtual crash really stands out is in rendering stunning diagrams and animations. So there you have it. You can use virtual crash not just for simulating crashes, but also for generating crash diagrams. Thank you for watching.